Hello everyone. Today we'll talk about the time value of money. I have already posted a video explaining the very basics of the time value of money. Today we will talk a little bit about those basics, or we will also, the major focus of today's lecture, today's video will be on practice of the problems, on understanding different situations where we need to calculate time value of money. But before we reach to that stage, I would like to discuss a little bit about the relevance of time value of money. Why do we need this kind of a concept in finance? So the major objectives for this lesson would be to understand the concepts of future value and present value, their calculations for single cash flows amount and the relationship between them. We will see how future value and present value are related to each other. Then we'll try to find the future value and the present value for ordinary annuity as well as annuity due. And we will also discuss about the present value of a perpetuity. Then calculate both future value and present value of a mixed stream of cash flows. And also we'll try to understand the effect that compounding interest more frequently than annually, let's say like half yearly compounding or quarterly compounding or monthly compounding, how does that affect the future value, and what is effective annual rate of interest? Why is it different from nominal interest rate? Okay, so we will talk majorly around those lines. So the first thing here is what time value of money actually is. Why are we talking about this concept so much? The concept says that money has some time value. So money's value is different at different points in time. Sooner you receive the money, more valuable it is than the same amount of money received later. Okay. So we, in almost as I talked about all this in my previous video as well, that you cannot even imagine an area in finance where you don't see the importance of time value of money, where you don't see the applicability of time value of money. So as I just said, that if some amount of money which is received early is more valuable compared to the same amount received later. I have explained it in that video as well. So how does that happen? If money received today versus money received in future, if they are they carry two different values, even if the amount is exactly the same, how would you compare? Right? We might have the situations where you may wish to evaluate two different projects, where one project has higher cash flows compared to the other one, but the second project may be giving you the cash flows which are little lower but early in the life, whereas those higher cash flows are in the later life. You cannot directly compare those two projects. It's not possible to compare those two projects, right? So that is the situation where time value of money will play its role. Let me show you what I'm trying to say. Let me explain it to you. Let's assume there are two projects, project A and project B. Okay. Let us assume initial cash outlay on both the projects. I'm sorry about it. Let's assume the initial cash outflow or cash investment in both the projects is exactly the same, let's say $1 million, okay? But when it comes to cash flows of the projects, let us say this project A, which is offering us higher cash flows compared to project B. But project B, although the cash flows are lower, but the cash flows are in the earlier years. Let's say it provides you the cash flows for up to 20 years. Up to 20, and every year let's assume the cash flows are exactly the same, which are $800,000. Okay, so every year this project is giving exactly the same. So within 20 years, the total cash inflow from this project would be this would be the total cash inflow, $16 million. Okay. Now project B gives us little less cash flows. Let's say it gives us $15 million dollars of the cash flows, in which we are getting $7 million in the first year and $8 million in the second year, but nothing afterwards. So it is $15 million of cash inflow. Now these are the two projects in front of us. They are not directly comparable. They cannot, like, you cannot say, okay, this project is giving us $15 million versus this project is giving us $16 million, so this one is better. If you will take the decision just based on this, you will end up making a wrong decision. Because remember from the previous video, if you have $10,000, your dad is the $10,000 that your dad is giving you today, you can invest those $10,000 somewhere else, and 1 year from now, let's say if the rate of interest is 8%, so that would be 10,800. Okay. So in that kind of a situation, like, if you have the opportunity to invest these funds, and definitely there are some opportunity to invest these funds at some specific rate, so by the end of 20 years, these funds might not be just $15 million, they might be something else, right? So whenever there is such kind of a situation, we always end up relying on the concept of time value of money. Okay, so the cash flows always remember, this is the basic idea for this, that the cash flows at different points in time are not comparable. Okay, the cash flows received or paid at different points in time are not comparable. Received or paid, whatever the situation is, if you want to compare these cash flows, you have to bring them at the same points in time. This line I'm drawing here, this is called a timeline. Okay, so this 0 time is the present time, and this is any time t in future. Okay, 1, 2, 3, 4, whatever. So we have two situations. If we want to make them comparable, either we bring them here For all the cash flows, you get the present value of those cash flows. Now, after getting this present value, all these cash flows are at same points in time, then you can compare them. Or the other alternative is get the future value of these cash flows. Okay, so whatever you are doing, either you are getting the present value or future value, but the thing is you have to bring these cash flows at a particular point in time to compare them. Okay, so this is the basic idea for time value of money. Whatever we'll be doing, that we want to compare the cash flows, we want to make a decision, and that comparison is possible only if they can be brought in the same point in time. Okay, so this time value of money concept is required if you want to value the securities or any other asset. You cannot like get away with this concept. You will need it for capital budgeting decisions, whether this particular project should be taken or not, because the project will be giving you cash flows and those will be at different points in time, and that you will be doing. Then cost of capital, working management, or lease analysis, in all these things we will use time value of money concept. Okay, so that's why this is the first thing that we are trying to learn here. And as far as the notations are concerned, I have already explained you as well, and these are the notations. PMT is for cash payment, which is like the regular payment of same amount at regular intervals. Then we use the PMT in our financial calculator. PV stands for present value, FV is for future value, T is for time, N is for number of periods. Time and number of periods can be different. Okay, time can be 5 years or 10 years, but number of periods, let's say the compounding takes place half yearly. So in 10 years there will be 20 periods. That means 20 times the compounding will take place. Okay, so the number of periods will always depend on compounding frequency. Then I/Y, this is the button that you will see on your financial calculator, which is interest rate, or you also can call it as yield, or this can be considered as R, which is rate of interest. Okay, so you will see these symbols interchangeably. Sometimes you will see this as small I also. So it's exactly the same thing. So this is the repetition of what I just explained. Now let's talk about this situation. Suppose that a firm has an opportunity to spend $15,000 today on some investment that will produce $17,000 spread out over the next 5 years. And how that is spread out in first year, the cash flows are for $3,000, second year $5,000, third year $4,000, fourth year $3,000, and fifth year $2,000. Now the question is it a good investment? A layman who doesn't have any idea of this time value of money, the layman would say, okay, you are investing $15,000 and getting $17,000 back, so it's good. This investment is worth it because it's paying you more than your investment, so you will end up making $2,000. But that may or may not be true, because as I just mentioned that the cash flows which are arising at different points in time, they are not comparable. If you want to compare those cash flows, you either will bring all these cash flows to present time or take all of them to the future time. So whatever way you want to adopt. Okay, this first cash flow, $15,000, since it is in cash outflow, that's why a negative sign is mentioned here. Okay, so these two concepts, when you are trying to get the present value, this is called discounting, And when you are trying to get the future value, that is called compounding. I would highly recommend you all to watch the time value of money basics video before you go further than this, because I have explained all those concepts, discounting and compounding, in that really well. Okay, so compounding is like when you want to calculate the future value, and discounting is to find the present value, which is like at time 0. And how do we use these concepts? That's explained in the other video. To compute these future values or present values, we can use financial calculators, or Excel is also a great tool that can help with with these things. I would highly recommend you all to practice as much as possible through Excel spreadsheets. I will post a separate video, and I will also post a link of a YouTube video. There are thousands of videos on YouTube which explains how those time value of money problems can be solved using Excel spreadsheets. So I will post a link of that YouTube video along with my own recorded video for those to solve the problems on Excel spreadsheets. Always remember that the employers are specifically looking for this skill in all their prospective employees. So it would be a great tool with you if you are extremely comfortable working with your with the Excel files. Okay, so always remember, you should practice Excel as much as you can. Ultimately, your target is to get into a good job somewhere, and everywhere, no matter how which employer you are working for, but Excel is the must-have skill that every finance student specifically should possess. Okay, so while solving the problems of time value of money, since we are using two of these ways, the financial calculator or spreadsheets, we need to take care of few things while we are solving the problems, be it financial calculator or Excel spreadsheet. If you want to get the correct answer, your cash flows should be entered accurately. And what does that mean? That means when you are entering the cash flows, you should specify whether it is a cash inflow or cash outflow. If you are receiving the money, it is cash inflow, and that should be entered as a positive value. And initially when you invest the money, okay, so that is cash outflow, and that should be indicated by a negative value. And I have explained how in the financial calculator you show those negative values. So right here, this is the negative value. Okay, so it shows that it is in cash outflow, and all other are cash inflows. If you forget to do that when you are entering the values in the financial calculator, and you forget to put this negative sign in front of it, your calculator will not answer you. I mean, it will show you an error. Okay, calculator is smart enough to understand that it's not possible that you are just giving and not getting back anything, or you are just receiving and not giving away anything, like when it comes to investment versus the return kind of decisions. Okay. So the problems that we will majorly look at, like the first of all, we will discuss the problems related to single amount, that you are investing a single amount today, and how much your amount will be like 5 years from now or 7 years from now or whatever. It is the similar example to what in the previous video was mentioned. When your dad gives you a single amount of $10,000 today, and after 4 years, once you'll be done with your college, how much that amount would be. So it's just some single amount and nothing was done in between. Okay, you invested that amount once and after 4 years you are getting your amount back. That is lump sum amount. Okay, so we will learn how to get the present value as well as the future value of that single lump sum amount. Then second kind of problems would be like where you are investing or you are receiving periodic stream of cash flows. Annuity means when you are receiving exactly the same amount at same intervals. So there are two conditions for something to be considered as annuity. First one is the amount has to be same. If you are receiving $100 a month, it has to be $100, and the time interval should also be exactly same. So every month you are receiving $100 consistently. Then it will be considered as annuity. Then it would be defined as annuity. If the amount that you are receiving is not same, if it is different, then those kind of problems would be solved separately. So that is considered as mixed stream, a stream of cash flows which is not an annuity, where either the amount is not same or the time interval is different. So that is considered as mixed stream of cash flows. So we will learn for all the three kinds, we will learn how to solve the problems. Like first we will understand, like we have to understand what the situation is, whether it is a single amount or it is an annuity or it is mixed stream. When we will talk about annuity, there is also a special case where whether it is a perpetuity or it has an ending date. Okay, so will it keep on going forever at the same rate, or it has an ending date, it will end at certain point in time. So we will talk about those things as well. So first let's start with the single amount. Let's learn how to calculate the present value as well as the future value of that single amount. Okay, so what is present value? It is the value of a future amount today. So how valuable that amount today is. Okay, and in the previous video, if you will look, I have already explained this formula, where this comes from. Okay, FV here stands for future value after n periods, R is the annual rate of interest, N is the number of time periods, PV at 0 means today's value, which is the initial principal or the present value at time 0. Okay, now suppose your banker offers to pay you $255.20 in 5 years if you deposit certain X dollars today at an annual 5% interest rate. What is the present value of that amount? Like how much amount would you like to invest to get $255.20? Okay, where interest rate is 5%. So look at this timeline right here. This timeline shows you the situation clearly, that after 5 years your banker is offering to pay you $255.20. Okay, and it would be deposited at 5% rate. So what is the present value? That means we want to get the value here at time 0. Okay, so to get the present value, if you will use the formula, it would be future value times 1 divided by 1 plus R to the power n. N is 5 here, R is 5%, so 1 plus R becomes 1.05. Future value $255.20 is already given. If you will solve it, you will get the present value of $200. This is what you get when you plug these values in the formula. Okay, let me show you how to get the answer using your financial calculator also. Okay, so show you all this here. Okay, let's have a look at the inputs. First of all, look at these 5 keys in your financial calculator. Okay, let's see. N, interest rate, your present value, payment, and future value. So these are the 5 inputs that we are always looking for. N is number of time periods is 5. Interest rate was 5%. Present value, we want to calculate this present value. We don't know what this present value is. Payment means like during that time period the regular payments which are reoccurring every after every fixed interval. There is nothing like that. Okay, so we will enter that value as 0, and the future value is $255.20. This is the future value. Okay, let's input these values in the financial calculator and we will get the results. N, 5 is N. Sorry. Then interest rate again is 5%, our interest rate. Present value we want to calculate, so we won't do anything yet. 0 is the payment, there is no payment. Future value is 255.20. That is the future value. Okay, since the banker is offering us, so we will receive it. I'm entering that value as a positive value. Then we want to compute present value, so hit this button right here. CPT stands for compute the present value. It is 199.9559, so it is $200. So our present value here would be $200. Always remember, it is a negative sign here. If 1 is positive, it will give us the answer as a negative number. If the situation is different, we have to invest, we have to repay. We will receive some amount today, we don't know how much amount would that be. At 5% interest rate we have to, but later on we want that amount to be repaid as like 255. So whatever the situation is, if you want to plug that number in as a negative number, this button right here, okay, able to show the complete calculator. Yeah, now it's better. So yeah, 5 is N, 5 is interest rate, 0 is payment, and that future value, we can input this future value as a negative number also. To enter it as a negative number, right now it is a positive number. If I will directly hit FV button here, so it will take that as a positive number. If I want to show it as a negative number, just put this, future value is negative. Now if you will compute the present value, now it will give you the result as a positive number. So this is smart enough to understand, like if present value is positive, future value would be negative. If that is negative, it would be positive. Okay. So this figure right here, it shows us that the present value of $100, which is at different discount rates, what would that be? Okay, so before that I want to show you one more thing. Okay, we know the formula for present value is Okay. So basically, whenever, sometimes these are the conceptual problems that you have to see what happens if t increases, what happens if r increases or decreases, what happens to the present value. Okay, so to understand those things, you need to think about the formula. So since r here is in the denominator, if this number will increase, if it will make the denominator bigger, and if denominator becomes bigger and bigger and bigger, the result of this whole thing will be smaller. Okay, since the denominator is big, the overall result will become smaller, so the present value will become smaller. And this is the relationship that we will observe here through this diagram. Look here, 20%, 10%, 5% and 2%. So as this rate is increasing from 2% to 20%, the present value keep on decreasing. Okay, so the present value keep on declining as this rate of interest is increasing, because we are discounting at a bigger rate. Okay, then let's talk about the future value. So future value is the value of some amount which we know today what that amount is, how much the present value would be in future at any point in time. So it's exactly the same thing. Let's look at this problem. Jane Farber places $800 in a savings account, paying 3% interest compounded annually. So compounding frequency here is also annually. We'll talk about some of the problems later on where compounding frequency changes. She wants to know how much money will be in account after 5 years. So she knows how much she is putting in her account today. Okay, so that is the present value that she knows. And she wants to know how much that money would be after 5 years. So she wants to know what the future value would be. Interest rate is 3% and we know the time period is 5 years. So again we have our inputs. N is 5, interest rate is 3%, present value is $800. Payment, again in this situation there is nothing in the middle, so payment would be 0 and we can compute future value. I will not show you the calculations. I want you to try these simple calculations because you have to start from somewhere. So start with these very simple things. I want you to solve this in your financial calculator. If you face any problems, feel free to contact me. Also, we will have a live class session. You can discuss, if you feel any problem, you can discuss your problem in that live class session as well. If you feel comfortable, if you don't feel comfortable, you can email me separately. It's up to you, whatever way you want to go for. But I want you to try it and solve it. Okay? So again, the same kind of relationship with the future value. Higher the interest rate, the future value will keep on increasing. Okay, and again the same idea or same technique is there. Once you are calculating the future value, so future value would be present value times 1 plus r to the power 10, right? So this r, as it will keep on increasing, since now it is in multiplication, so if you will keep this one increasing, the overall result will keep on increasing. That means the future value will increase. So what happens if r increases? What happens to the future value if r increases? The future value also increases. So these are the conceptual questions. Always remember, you can be asked those kind of questions, that what happens if this changes, what happens if this changes, what happens to the future value. Okay. So this is exactly what this diagram is showing us, that if the value of r is increasing, the future value is increasing. Okay, we can always see these relationships based on the formula that we have. After that, we will talk about annuities. Let me here just give you what annuities are, and in a separate video we will solve those problems related to annuities. Okay, so annuity, as I have just explained, that it is a stream of equal periodic cash flows over a specified time period. Okay, so there are two conditions. One, the time period has to be constant. The time interval should be constant. Second, every single cash flow should be exactly equal to the other cash flows. So they all are same. All the cash flows are same. These cash flows, no matter, it can be inflows or outflows, that doesn't matter, but the amount should be equal and the interval should be equal. These are the two conditions for something to be considered as an annuity. Okay. Now, this annuity can be annuity, ordinary annuity or annuity due. If the problem doesn't specifically explain anything, we always assume that it is an ordinary annuity. Ordinary annuity means the first payment occurs at the end of period. For example, today at time 0 you won't get anything. You will start getting it starting from time t1. Okay, let me show you. I think there should be, yeah. Annuity due is where the cash flows occur at the beginning of each period. Let me show it to you on the paper, making a timeline. So if you want to differentiate between annuity due and ordinary annuity, here is the timeline. Okay, let's say 4 years time interval, 1, 2, 3 and 4. The second one here again, 0, 1, 2, 3 and 4. So if your cash flows start from period 1, that means at the end of this whole is the first time period, right? This is the beginning of that first time period t1, and this is the end of that t1. Okay, so when your first payment starts coming at the end of this time, so let's say $100 here, here, here and here, then you want to calculate the present value or the future value of all these cash flows. You can calculate both the present value as well as future value. If you are calculating the present value, you are bringing everything here. Okay, same way. The other situation can be your first payment starts today. Okay, so what happens in that situation? When your first payment starts in the beginning of each period. So beginning of period 1 would be here, beginning of period 2 would be here, beginning of period 3 would be here, beginning of period 4 would be here. The payments are exactly the same. These are also 4 payments, these are also the 4 payments, but here the first payment was at the end of the first time, here it was in the beginning itself. So this is ordinary annuity and this is annuity due. Okay, in our financial calculator there is a function that helps us to change between ordinary annuity and annuity due, but I would always suggest you not to do that. The reason is, once you change the settings in your financial calculator, normally it calculates everything based on ordinary annuity. If you change the setting to annuity due, for your financial calculator to solve other problems using ordinary annuity, you need to change the settings back. Okay, what I would suggest you is simply calculate everything based on ordinary annuity and multiply that by 1 plus R. Now you will be thinking, why am I saying it? That multiply everything by 1 plus R. Let's assume here, let me show you, if you want to calculate the future value in both these situations. This is the formula for future value, right? So what you will do is, you will calculate this one here, this one here, this one here, right? So your basically the time interval, this, and this. If the same thing happens with the annuity due, you want to calculate the future value. So basically one time extra you are getting it, because future value has to be at this time. So you are getting an interest on, in the first year you won't get any interest on this $100, but here in this case you will get it, okay? And then interest on interest, interest on interest, right? So it becomes one more interest payment, okay? If it is annuity due and you are getting the future value, it becomes one more interest payment. If it is the case of present value, it becomes one less, because here it is already present, so it becomes one less. So you want to subtract one here, so the way for that also, multiply it by 1 plus R, and you know this is in division, this is in multiplication, so overall result would be, it would be subtracted by 1. So long story short, the best way to get anything for annuity due is calculate normally, whether it is the case of present value or it is the case of future value. Calculate it normally as ordinary annuity and then multiply your result with 1 plus R, no matter if it is future value or present value. This will take care of that annuity due part, okay? So that's all for this lecture, and we will this video we will solve the problems on annuity due and ordinary annuity in the next video, okay?